Hello. We've started recording. Okay. So today, last day, we saw this very interesting classifier called the support vector machine, and we were seeing how to handle. What were we handling? Why did you take the slack variables? Do you recall? We took the slack variables because in case to deal with small amounts of non avoidance of non-linearity. Sometimes reds can come into the territory of green, and we do not want the model to fail in those cases. Therefore, we made a soft SVM classifier and we derived the objective function. And if you recall, we did derive the Lagrangian and we derived these alphas, whether Lagrange multipliers, and we derived it in terms of the Lagrange multipliers. So now what is my next step? Can you tell me what should I do to the dual? What is my objective of the dual? I will maximize the dual, right, with respect to the alphas. And then I'll get the, so if you can recall, f of x is equal to, or x star is equal to max of alpha, all the Lagrange multipliers, alpha, beta, whatever you had over here. So I think we had two Lagrange multipliers, right? Where is it? Yes, we had how many Lagrange multipliers? We had one alphas and betas. Correct. So we have two Lagrange multipliers and minimum of, with respect to x, right? This is what we did to find the optimal value when strong duality holds. And it holds for SVM. Because clearly from the diagram, right? Clearly from the diagram, can you tell me why will strong duality hold? The strong duality, when did it hold? When the Slater's condition did hold. Slater's condition was the inequalities hix less than equal to 0 for some x, right? For some x, it was not for all I. This was the inequalities were less than 0. So what is my inequality? What is my, so I think I have written, yeah, I have written this down. Right, for one, once you reach the optimal point, do you see why will this hold? This is because you will have this objective decision boundary and you will have at least one point like this, right? Where it will be strictly greater and not equal to 0. Or strictly, like, for example, 1 minus epsilon I minus yn transpose w transpose xn plus b, right? So this less than 0, there should be at least one point for which this should actually hold, correct? So because you would have these w's for which clearly you would have these conditions where at the best condition, at the best optimal solution, what will you have? You will have these positives and negatives in both directions. So they will not be, so they will just satisfy the conditions and not be equal to 0. So they need not be equal. That is, they do not lie on the plane. They need not be on this surface. And complementary slackness, so slack variables help us get that. So that is just a side note, so that you know that this equality holds. F of x star equal to this min max problem. Otherwise, we had seen it is always less than equal to. But in this case, we will have a equality because we can see for some values of x, this condition is going to be satisfied, right? Now, what is if I think you may have mistaken me, like this should be W, right? In our case, some value of W, because W is the variable we are optimizing. So for a particular W, you will have all these constraints to be held, right? So any questions regarding that? When you have the optimal value, you will have this. So at least for some W, all the points would not have the whatever you desire, right? So you will get greater than, so this inequality will be gone. So this is, you can also formulate this, since you have used slack variables, you need not use equality as well. So if you just remove this is the same, right? Because it's a continuous surface. So automatically slatus condition hold. So there is not a much of a problem. Do you get me? So this equality need not be actually holding. Okay, therefore we have strong duality. Now my question to you is, so the line of thought that we are trying to go to is, we are trying to maximize the alphas to get our solution, right? We'll see how we'll do that. So the objective is clear, right? So I want to maximize this. So let me just write it down once again. Half summation of alpha I equal to 1 to n minus summation of j equal to 1 to n, or let me write I equal to 1 to n, j equal to 1 to n, alpha I alpha j, xi transpose xj, and yi yj. Okay, so this is what I write down. I'll write it a bit differently, and then you will see the form. So I'll write xi yi transpose xj yj, right? And then I will write alpha I alpha j. Does this look something that you already know? And I have already done this before. Do you know this form? What does it look like? So if this was the matrix, so you have this double summation. What is it? It's a quadratic, right? Between xi and xj. Okay, so just to warm you up, what is the first part? How can I write it as a vector form? Can you tell me? I can write the first part as alpha transpose 1, right? Where 1 is 1, 1, 1, 1, 1, 1. Yes or no?
Yes.
Okay. So now I can also, in the second part, can I write it in this form? Alpha 1, alpha 2, dot, 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 alpha n, and something. Let me represent this as some x tilde and some x tilde I and x tilde j. Okay. So x tilde transpose alpha 1, alpha 2, dot, 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 alpha n. So we can do a simple test to look at that. Very simple test. So just see the ijth component, right? So what is this double summation meaning? This is a quadratic in the x transpose x, correct? All these. So therefore, everything that is related to the I and the jth component in this matrix should be xi yi transpose xj yj, right? Yes or no? So if I have a matrix, I represent this as a matrix G, and I write alpha 1, alpha 2, dot, 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 alpha n. This is a vector, and I will write alpha 1, alpha 2, dot, 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 alpha n. This is another vector. So therefore, you see, you get this term, right? From the ijth term, from the ith term in alpha I, and the jth term in alpha j. When you multiply these two, you will get one term that will give you this. You can do a simple validity check. How can you do that? So you can do something like X transpose GX and see how does it look like. How does it look like? Let us see how does it look like. Can you tell me how does it look like? So G is say 1 G11 G12 dot 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 G1n, right? G21 dot 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 G2n, Gn1 dot 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 Gnn. And I think I had given this as a homework in the discriminant function question. Okay. Xn, correct? So now what will you get? Just give me the first element that you will get from multiplying the vector with this column matrix. So you will get summation of G. The first term will be, what will it be? G11 x1 plus G12 x2, right? Dot 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 G1n xn. ठीक ना भूल?
Yes.
And I'll get dot 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 summation of Gi, the ith row, j equal to 1 to n into xj. Do you agree? For the ith row, for the jth row, for the ith row, just from the first line you see, the running variable is j. J is from 1, 2 dot 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 n. Correct? Any doubts? Do you agree? Okay.
Yes.
So now you tell me. So I will get another summation, right, from this matrix, this value, right? This
Yes.
is this is a dot product. This is one vector n cross 1. This is 1 cross n. This is the dot product. So I will get xi summation of gij xj, j equal to 1 to n. So do you get? So see, this is when you are confused, just try and write down the entire thing. So we have written it down. Did you get the original form that I was saying it will be? Correct?
Yes. Yes.
So now, and you already know that X transpose, these components, you only told me in the last class that we had also done this before, that these are components of ijth component of which matrix? X transpose, X tilde transpose, right? If I represent that these elements are coming from the X tilde matrix, and this scalar is coming from this matrix, right? Ijth element of this matrix. Because this is the all possible dot products. Is it clear?
Yes.
Okay. So now what is X tilde? Can you tell me? What is X tilde? I'm just writing the vector form because this is how what we'll implement in the code. That's why. Otherwise, I would not have bothered. And this will also help you solve a lot of problem in your exams because people will ask regarding this a lot of questions. So X tilde
X matrix in row form and Y matrix in column form. Dot product.
Okay, I can write X. Y is a scalar, right? Again, I'm telling you last time.
Acha, yes.
So that's why I could take transpose. I couldn't have multiplied if X was a. These are the plus ones and minus ones. So you're right in a sense that what will it be? It will be, if you write it in terms of the rows, it will be y1, y2 dot 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 yn. Yes or no?
Yes.
So each of the row will be x1 y1 x2 y2 dot 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 xn yn. I guess you understand this, right? Okay, so now I already got this. So let us represent. So therefore, what is the objective I got? I got L of alpha is equal to alpha is a n-dimensional vector. What is n here? If you recall training examples, right? So it is alpha transpose 1 minus half alpha transpose G, or let us, you can write X transpose, where I'll just write G here. Why I'll write G, I'll tell you. So G is equal to capital Y, diagonal of Y, diagonal of Y into X, into diagonal of Y into X transpose, right? That's what we wrote here. This I'm representing as diagonal of Y, correct? Or this is X tilde transpose. Any questions? Can I proceed? Okay, so if you see this, you can see that. So what can you say about G? What type of a matrix is G? What type of matrix is G? This will give you, so if you see that, what will you get? X tilde transpose, alpha transpose, alpha. Or let me write it in terms of V also. What does it mean? V transpose or X tilde V transpose X transpose V. Is this correct? Is this the same thing? Do you agree? I am seeing G. G is equal to X tilde. Correct?
Yes.
And X tilde, we can see that G transpose is equal to G. So G is symmetric. And now this is equal to X transpose V squared, which is greater than equal to 0. Correct?
Yes.
So what does it mean? It means that G is positive semi-definite, right? We have done this. That is, all eigenvalues are greater than equal to 0. See, if it is equal to 0, then I have a problem. Because why? Can you tell me? If there is one eigenvalue equal to 0, what does that mean? If G is semi-definite, what does it mean? G is semi-definite means simple, right? There is an x such that gx equal to 0. 0 into x. Yes or no?
Yes.
Which means x is in the null space of G, right?
Yes.
So if this is the case, then do you see that L alpha? So L alpha, what will it become? So alpha transpose 1 minus maximum of L alpha. What will it become? This is negative. X transpose Gx. Why is it essential? You just look at this. Can you tell me why is it? Because I know that this is greater than equal to 0, right? This term, because it's positive semi-definite. Correct. I just showed this term. alpha transpose G alpha. I just wrote X instead of alpha there, V instead of alpha. That is already greater than 0.
Yes.
So now I know that this is always greater than or equal to alpha transpose 1, right? Your negative number.
Yes.
Okay. So now if I max out alpha, so see if there exists a null space, the minimum value is 0, right? That means there is this huge number that I could have subtracted, a big number that I could have subtracted, which can be minimum number I can subtract, or the max is 0. That will give me the optimal value. Now you see, if there exists x such that gx is equal to 0, what will happen? Do you agree that this will be the maximum value alpha transpose 1? This will be the argmax, correct? This will be the maximum value of L alpha. Did I write a wrong inequality? This is greater than 0. I remove the negative sign.
You are
Is this the
decreasing
inequality?
something. Yes.
Yeah. Yeah. Because I am subtracting something off, the original maximum of that was the maximum of alpha to whatever L was some value. I am taking away. I am just adding. So I'm taking the minimum, whatever is the minimum. So it is greater than. So if I put this entire thing as greater than 0, which means minus of that is less than 0. So it is always going to be less than this. Yes. So the max must be less than this, correct? Okay. So now, do you agree that this will become C into N, right? Because what will alpha become? The alpha components, you will get a solution here. It is okay. Our max of alpha you will get. But in my previous day, had I no C here, in my previous day, I did a soft classifier, right? You remember there was this soft classifier I put because I want to see mislabeling of points. If there was a mislabel of points, if there was non-linearity and so on. Correct? Do you remember? And that was giving me the constraint that C has to be less, the alphas must be less than C. If that constraint was not there, that is a hard SVM that I taught you in the first class. So in hard SVM, what happens? This is not there. What would have happened in hard SVM? In hard SVM, had G had a null space, what would have happened?
Like you could not bound that alpha t. That is
Good.
alpha 1.
You could just keep on multiplying K alpha. So this will become infinity. So no solution. So this is what is it showing, that in case of this, which means that this G will be greater than 0, that is positive definite, if linearly separable, right? If this point was linearly separable, it would have been, that's why you are not getting a solution, right? Whenever there will be no not linearly separable, you cannot get any solution in hard SVM. We saw that. Correct? Any questions? So this is also a way to analyze the SVM. Now we have analyzed it well. Now, how do we deal with non-linearity in data? So first, one way we have used slack variables. Now, if my data is something like this, what will I do? There is a decision boundary, right, that I can use, and that can also be a hard decision boundary. I can still have a SVM sort of a classifier. Yes or no? If data is non-linear, you see that the SVM has, so this comes the kernel trick. The SVM has as an option to make it non-linear. So again, do you recall the formulation of SVM? It is summation of I equal to 1 to alpha I minus half I equal to 1 to n, j equal to 1 to n, alpha I alpha j, yi yj, xi transpose xj. Right? You can deal with these non-linearities by making these non-linear. Right? Right? I told you in kernel ridge regression what we could have done. X could be transformed into some phi of x. Right? Which could be x square, xn, something like this, right? And that was defined by phi transforms. This is the generating function. Right? So instead of using x, I could use phi of x, right, as my variables. Same logic as ridge regression. Do you agree? So for example, if I have a quadratic in ridge regression, I can, and linear regression, whatever is the data, I can make my features x comma x square, even if the feature given to me is x, right? From x to, I can have a mapping that will give me my matrix from this vector, from this a vector from this scalar, right? Do you agree? So phi is a mapping from Rn to Rm. So which can be any combination of the features, right? So give me an example. It'll be easy. So say I have features x1, x2. A phi can be something like this: x1 squared, x2 squared, 2, x1, x2. Right? This can be a phi. All phi is a functions, all functions, type of function that you can generate out of the variables in the original x. Right? Do you agree? And then I can deal with this non-linearity.
Any
Say
possible combination.
If I'm able to map these circles somehow, right? I'll be able to find a decision boundary. Yes or no? So I have x comma y. If I can somehow make it x square plus y square as one of the features, I can make a circular decision boundary, yes or no?
Acha, like it will become constant and you will separate.
Yes. So in x square plus y square plane, that will become a linear separator, right? So when I will transform it into phi space, this can become linearly separable. The data points will be transformed. You can ask me what are you getting stuck with, and I can help you with that.
Means here you are randomly assigning phi, but how can you assign phi?
Exactly. So, but if you assign phi, if you know the phi, you can do it, right? That you understood. That I can always map to a non-linear space, so that in that space it becomes linear. For example, x and log x, right? So if I have y equal to log x and x, this is the graph, log scale graph, correct?
Yes.
But if I change x to log x, I will get y equal to x graph, yes or no? right? It will become, these features will become linear or not, and I will be able to fit a decision bound. So I can do all these transformations into a non-linear space. More non-linearity I put in, more I can map this linear, non-linear data set into higher dimensional linear space, right? So let us think for the time being, we know phi, right? Okay. I'll tell you how will you know phi. So I will be using, instead of x, I will be using x phi of xi times xj. Okay. Right. Same thing for all x, I will be transforming it into the new space and then training the model. The rest of the things remain the same. Do you agree? Because there is a dot product. There is a dot product. I am solved. My problem is solved. I can generate it into any dimensional space, but I'll still get a scalar, right? At the end of the day. Right? Since it's a dot product.
Means since phi is also of each m dimensions, so dot product in.
Yes, both will have the same dimensions. It's a dot product. So converting it to any m dimensional space still results in a scalar. Okay, good. So this we do not generally know, because calculating phi and phi transpose or for all the x's is a very, very lengthy process, right? For all x. For all x, you have to calculate in all x Rn. Whatever you get. So it may not be a good choice. As you are saying, we do not know phi. So what do we know? We know something. Do you agree that phi transpose phi is a similarity measure? Similarity measure as in any x transpose x is a, or x transpose y is seeing how similar two vectors are, right? It is nothing but x, y cos theta, right? Maximum being when they are equal. Yes or no? Correct. Dot product is the seeing how they are close to one another, right? How the vectors are inclined to one another. Do you agree? Because vectors farther away, they are more unlike to be similar. Vectors together having same dot product are together, right?
But Dada, here you are taking x transpose y, but there you are taking phi transpose phi. X transpose y.
Phi
So
transpose
phi. So the phi's are already similar. So means you will always get dot
phi
product.
is a function, right? Phi is a function. Phi is a function from Rn to Rm. So how can they be similar? So if x is not equal to y, then phi of x is also not equal to phi of y, right?
Oh,
Phi is a function. It's a function. Okay, so here I can represent that by a single function, which is called a kernel. The kernel is defined as phi transpose x phi. So we know this. This is a hyperparameter. You can choose. This is a kernel. We don't need these generating functions, right? We do not need these generating functions ever, because if we know k, once we know k, we already know all combinations of these, right? If k is known, what does kx? Can you tell me what does k of xy map to? What does K map to? Kernel. It maps
Like
x,
x
comma
comma
y
y
pair.
to a scalar.
Good. And it is a similarity measure. We forget about phi's now, but you can use directly what x and y are, because in the SVM equation I have this dot product. I can do all these things. This is the beauty of a dot product, because dot product allows me to change my space without doing anything. With having the features will change, but the algorithm will not change, because only the x is changing, nothing else is changing, right? And now it also has become very fast, because I can use k of xy instead of using all those difficult things that I was using, right? All fees that I was using, all the n dimension. See, do you agree that if I have to calculate n, which is infinite dimensions, so I'll show you one infinite dimension kernel. So then the dot product would be very, very difficult to compute, right? It will take a lot of time depending on the size of phi. But k, if it is a function, it can generalize all those difficult dot product into a single computation, right? Do you agree? It makes the
Yes.
much simpler than phi transpose phi. But remember, I will tell you to remember one thing. There is this one property of k. So do you agree kxy has to be equal to phi? This is one property. There has to be a function. There exists a phi, either implicit or explicit. So if it is implicit, you are done. Like explicit, you are done. But you are done always. But if it is implicit, that is, you cannot write a closed form for phi, then you have a problem, right? You cannot break it up. So in that case, there is a test called a Mercer's test to check if it is a valid, any function is a valid kernel or not. It has to satisfy two things. One is, just you need to know this as a fact, because this can be, you may have to use it, because why it is true has to be done in an optimization course. So kxy equal to, or in a higher machine learning course, because that will take 2 classes in itself. Symmetry. So this is pretty same. No, I don't think I can do that. I think it will take 1 second. So this is, symmetry is true, right? Because I want distance to be same, like k of xy to be equal to k of yx, right? I don't want x transpose y to be not equal to y transpose x. Do not want this, right? Do you agree? And this is not possible in if it is a linear case, but in case of phi, can even phi transpose x, phi of y be equal to phi not equal to, can this be possible? Can it be possible? You tell me. Can you generate one x that this is possible? That dot products are commutable, right? For real valued vectors, these are real vectors, all real, right? X dot y is equal to y dot x, right? Yes or no?
Yes.
So should you get different outputs? So phi transpose x into phi of y, that is k of xy, right? Yes or no?
Acha, the one
And
thing
phi
to ask.
transpose y, just prove this na, LHS is equal to phi transpose x, correct? This is how we defined it.
That it will be like x1 y1 plus x2 y2, and right side
Correct.
will be
So
also like
this
that.
is also, I can write this as same. Well, dot products are always commutable. X dot y is not is same as y dot x.
Acha, yes, yes.
I'm just erasing this so that when people read, they are not confused. So dot product is, I'll write the proof as well. Dot product is commutable equal to kyx. The second condition, can you tell me what will it be? So what is the, so alpha transpose 1 minus half G alpha transpose G alpha comes from this fact. I don't know why people do not do this, but it's very simple. What did we find out? G has to be PSD. Yes or no? G has to be a positive definite matrix, and G was equal to x tilde transpose. Correct or wrong?
Yes.
So which G of ij is equal to k of xi yi xj yj. Yes or no? That's how we saw that. It's the element dot product or whatever it is. So if normally what it was, normally it was xi transpose xj yj, right? This is how what we found out, right? Right now. Right?
Yes.
So now if I have a kernel form, I will have k of xi yi xj yj. Correct? Yes. Instead of this door,
you will pass through phi and you will get this.
yes, phi of xi yi transpose. Yes. So that is going to be, so whatever I wrote in this quadratic form, I am writing it in this. I hope you get the beauty. So now you see G has to be PSD. So kernel K has to be a positive definite matrix. Positive definite matrix. So I'll just write this as K of x tilde or x tilde. Right? K of x tilde. This is in a matrix notation I'm writing. Okay. These are matrices. And what I mean by this is this has to be a positive definite matrix. K of x tilde. Now you tell me for all x, right? For all x tilde, for all data sets. Yes or no? It has to be positive definite for all data sets because you cannot generate any. So now your choice is K and you can be given any x and you should always return me a positive definite matrix, right? Choice is, look at the game, K. I will give you
The one thing to clarify.
x. Yeah, tell me.
Yes, means earlier you were taking two values. Now x tilde and x tilde they are matrices. So you will conduct dot product of two matrices. Or the phi
Dot product
of
as in outer product. This one. Yes. Phi of x tilde, whatever it is.
Acha, it will return a matrix then.
Yes. That
Okay.
matrix have to be positive definite. This is a matrix. Again, a n cross n matrix, right? Because it's a similarity between all those n vectors. Right. It will do a constructive example, it will become clear. But if you're not following it, then you should always go back to this and then come back. Go back to this. This is very easy to follow, right? It's opened up in a linear form.
Yes.
So now you have to have K to be always positive. It should give me a positive definite matrix always. So when will it be positive? Possible. It will only be possible when Kx positive definite itself. It's a positive definite function. So if this is true for all xy's, then it will always be true, right? You can choose any subset and that will be true. Correct? It's the same. So in functions, you write positive definite this way. Since K is a function.
This value will be greater than 0.
Yes. So these are the two conditions you have to, since you have to make G to be positive definite, this also must hold. Clearly we can see because we have to get all the x transpose x to be such that G always gives me positive definite. Okay, so this was a side note, maybe useful sometimes, but most of the cases, if you write it in terms of phi transpose phi, you will be able to do it. So let us take some examples of kernels to concretize things. Okay, let us take the example of kernels. One example is already linear kernel. You can always use kernel in all data. I mean, machine learning, in deep learning, in PCA, everywhere you can use kernel because dot products occur always. So linear kernel is K of xy is equal to x transpose y, right? This is a linear kernel. Okay. This is the normal kernel that we already had. This also can be represented as a kernel, right? Where what is phi? Can you tell me what is phi? Phi of x is? Ball rate. This is very simple.
X. It is x.
Yes, identity map. This you can just write as some phi transpose x, phi y. So this is equal to, so identity mapping to say quadratic kernel. There are many kernels. I'll give you 3 examples. I think that is more than enough. So let us take a quadratic kernel K of xy. So this will help you to do a quadratic. So if you have a separating something like this, right? You want a quadratic function. So once you visualize this, it becomes very simple. So now I can always plot this large margin quadratic, right? Yes or no? Correct? Yes or no? If the data was quadratic,
yes,
I could always fit a quadratic. In this case, even linear thing is fitting, but yeah, I think you get the idea. I'll take some points inside this, then it will not fit. Okay, so then what will be the quadratic? What is a quadratic? X transpose y whole square. Let us see why it is a quadratic. What features it is using? Let us see. So now you would want, what should be the features? You would want your features to be x1 squared, x2 squared like this, right? Phi of x. Yes or no? Let us write x is equal to x1, x2, dot, xn. Right? So what will be k of xy? Summation of I equal to 1 to n xi yi. Yes or no? I'm trying to find the phi. The phi will give you the type of decision boundary you will get, right? Because this is transforming the data in the space you need. So at quadratic, if you plot a quadratic normally x squared like this instead of, and then you plot x squared in terms of this, then you'll get a linear line. Yes or no?
Yes, yes, okay.
So then k of xy, what will it be? It will be xi square yi square I equal to 1 to n. Okay, clear? Plus 2 x1 y1 xj yj. Correct? Or just this? I can write j greater than I or something. Okay, right? For example,
Yes,
if it is
yes.
2, yes. So now can this be represented as a kernel? Can I write it as phi transpose phi? So if I write phi as x1 square, x2 square, dot 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 xn square, and then I write, what do I write?
Like 2x1 xj.
X1, x2, x1, x3, dot 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 dot, all these. Correct? Even if it is, I can just write I not equal to j, and then that will also help. I can just remove the 2. है ना?
Why did you take the root?
Just one moment. I shouldn't have taken root. Root came by mistake. So your phi of y is y1 square, y2 square, dot 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 dot. Then phi y1, y2, y1, y3, which are all these. Correct? So this is why I took the root. I was thinking of root 2. Because I cannot write x1, y1, y2, and y2, y1 in the same vector. No, it doesn't make sense. I can do it, but it is not useful, right? It is just increasing my overhead in my algorithm, right? Okay,
Yes.
this is why I wrote a root 2. This is one, and I will show you one more implicit for, this is called the always used radial basis kernel. Why it is used, you can easily understand now. See, k of xy is written as e to the power of x minus y square. Does this look familiar? Why is it very essential? Can you tell me? Since, so this is the distance, right, between x and y. So you would give, if they're far away from one another, right? If x, distance of x and y is greater, then kernel of xy is 0. Small means 1 by e, sort of an idea, right? But the
Like
major
you
idea,
bound it between, because distance is positive, so you bound between 0 to 1.
not only bound, it is also, if you just take, if you expand this, what does it actually mean? It means you will have all this form, right? So if you just take this, take one of these variables, so e to the power x minus y whole square, if I take one of these as my variable and expand it using a Taylor series, I will have x minus y square, x minus y to the power 4, and all these terms will come up, right? So these are going to give me all the valid kernels. So this is not exactly a valid explanation, but you will have all the e to the power guarantees that I will be having all this metric, right? Moments between x and y. Right? It's a two variable Taylor series you have to expand, but I'm just giving you an overall intuition. Isn't it? You will have all these terms, like all the comparisons will have to be done. Clear? So this will give you a very complete. So generally e to the power, this is used. This is foolproof. Because this can work for all my cases, quadratic beat, quadratic, cubic, 2°4 and so on. Right?
Yes.
Okay. Okay. Now we have done, so kernel and all we have understood. These are all design parameters we can choose. Now, what have we not done to complete SVM? Only one thing is left, that is to show you that what is left? Just one more thing. How will you find the actual values you need is W and B, right? You don't need all these other things that you got. The question is, how do you find the primal solution? If I ask you this question, how do you solve the primal solution? What will you tell me? So I'll just first, to understand that, let us understand what is called a KKT condition. Okay, this is essential to understand a little bit of this. Essential to understand is Karush, Khan, and Tucker conditions that we have. Karush, Khan, and Tucker conditions of strong duality. When strong duality holds. So when does strong duality hold? When? Can you tell me?
Oh, you like PhD, that one.
No. Alpha, beta, minimum of x. We saw the Lagrangian, right, last time? Correct? They are equal. You remember, right? So when we saw the
That graphical part though, maximum and
yes,
minimum.
when we solve the Lagrangian. So I have some space over here. Yes, the maxima and minima part. So when if star x, so KKT conditions. So I know one thing, max of alpha, beta, whatever. Let us write only one Lagrange variable for the time multiplier for the timing for the understanding. Mean of x. Right? So now I tell you if they are equal, right? So I will be able to give you a solution, say alpha star. So alpha is for the positive constraint that is less than inequality constraints, and beta is for the equality constraints, right? So do you remember what was the formulation of this? So it was max of alpha, minimum of x, fx plus summation of alpha I, hi, x I equal to 1 to n plus beta I L beta j Lj j equal to 1 to m, right? For which question? Minimize f of x such that f of x is equal to 1 to n. Right? So this is the formulation of this. So it was max of alpha, minimum of x, fx plus summation of alpha I, hi, x I equal to 1 to n plus beta I Lj j equal to 1 to m, right? For which question? Minimize f of x such that f of x is equal to 1 to n. hi less than 0 and Lj equal to 0, right? This was the primal. And we wrote the dual using the Lagrange multipliers. Right? So since say you have an equality solution, say x star, alpha star, and beta star are your solutions. Right? So if this solution exists, do you agree for the first case? Yes or no? Do you agree? At optimality, the gradient is 0. Right? Derivative is 0 at the optimal point.
Yes, yes.
So on the right hand side also, 0 belongs to the derivative, whatever the gradient. So you would be able to find that 0 even in the Lagrange case. So this condition is called
0 belongs to
the
means.
first. So I mean, so say I think you have done this. So if I put at x star, then I can simply write. What can I write is I can write. Say I give you a function like this. So you can think of it this way. Equal to also you can think of, but for the exact truth, say you have a graph like this, right? Mod x. Do you see that the left hand derivative and the right hand derivative are different? The limits, like one is going this side, one is going this side, right? So this is called a subderivative, subgradient. All values in between. So 0 is also a value between. So -1 to 1, all values can be your derivative, right? For mod x, since because you cannot solve the derivative, your derivative can lie anywhere between that because you don't have a smooth function piecewise.
Means right side tends to 1 and left side tends to -1 like that.
Yes, yes. If you
Acha, acha,
just
acha.
solve this limit, you will see that. But it is not required. So the 0 belongs to means just that optimal point must exist. Forget about that.
Means
Must.
one such x star should give 0.
Yes, one such x star should give 0 in the optimality. They're in the optimal. So in some cases at the optimal point, there can be many derivatives. They're called subderivatives. As you can see in your class 11 example, that it can lie anything between minus all are valid answers. Or that's why we say the derivative does not exist. But in the case of the subderivative, all are valid answers. Therefore, we say 0 belongs to the subderivative at the x star condition. So this is called the first, the stationarity. So at stationary condition, your derivative will be 0, right? It has to be 0. Right? That's how we found out the maximum value. We minimize it, right? We use this to minimize, right? We set this equal to 0 and then found out g of alpha beta. Correct or wrong? This is called a stationarity. You remember, right? Here, we minimized x by setting the values of it to 0, right? Yeah, we took this quadratic example where we took the derivative with respect to w and set it to 0. Right? Okay. So if that is okay, so then this is the first called the stationarity. Second condition, very easy. That is primal feasibility. What is the primal feasibility? We have three conditions. That is primal feasibility, the complementary slackness. We'll do it one by one. Just look at this. Your primal feasibility has to be the original constraints, yes or no? This is trivial, must hold. Hi of x where initially have to be less than 0, therefore they must, for the optimal point, they must be 0, less than 0 and equal to 0 respectively. You can ask me if you are not following. What was the original question? The original question was minimize x subject that hi of x is less than 0 and lj of x is equal to 0. Yes or no? So when you
Yes.
get the solution, they must be validated, satisfied. We saw that, right? We taking intersection of sets. There's a convex set. They must be valid at the end of the. Since this is a. So this must hold. This is by definition should always hold for a solution, right? Okay.
Okay, means the solution set should satisfy these inequalities. So you.
It has to. It has to. It is by triviality. It should hold, because in the question it was asked that they must hold this inequality. Otherwise, there is not a solution. If not hold, not a solution. As constraints of primal are not satisfied. Okay, now the dual feasibility. What does it mean? Again, alpha i's have to be greater than 0. We have seen that, otherwise we will not get the formulation itself. Right? Again, by construction. Right? When we started off, we told that alpha I has to be greater than 0, right? Otherwise,
yes.
where is it? Yes. If it is not greater than 0, this entire argument of this being less than 0 will not hold. And we will be at a problem. Correct?
Okay.
So at the end of the solution, this alpha I, because that's what we use to find out the lower bound and find out the solution. So at the end of the day, alpha I must be greater than 0. It must hold always. Otherwise, there's not a solution again. So that is dual feasibility. So we have shown that primal feasibility, that is hi of x being less than 0 and lj of x equal to 0 must hold. Dual feasibility. These are by construction, they have to hold. These things are not going to be questioned to you. The only thing that will be useful is called the complementary slackness. And we will show that. What does it mean? And I will derive, I will not give you the complementary slackness first. I will tell you to find it yourself. So what do I have? I have f star equal to maximize over alpha comma beta, or you can also write minimize over x, maximize over alpha comma beta. Right? These are the steps. I just wrote the minimum and a maximum out each in and out because L is well defined. I can do that. For a equality case, so if you for equality case, say it will be, say the solution is alpha star and beta star. So I can write this as minimum of x, Lagrangian of x, alpha star and beta star. Correct? These are two different variables, right? I can maximize one and minimize the other because equality is holding. And I have shown that if equality holds, I can do this. Like for example, maximize over x and minimize over y, x square plus y square. If you give me these values, I can always like give me one example where minus minimize over x and maximize over y, right? This is equivalent to saying maximum of y, since these are separable variables, right? So what is the minimum value of the maximum value of y? You have minus y squared, that is 0, right? And minimum of x square is again, so you will get x square, minimum of x square is equal to 0. Similarly, if you did x first and then y, it didn't even matter, right?
Okay.
So it doesn't matter if I do a minimum first or a maximum first, if the variables are different and they are not related to one another. Like they're not constrained. So the slack variables are really not constrained to be less than x or something. Are they constrained? They're not, because that's why we introduce these variables. Okay, so now can I write this as minimize over x, f of x plus summation of I equal to 1 to n alpha I star hi of x j equal to 1 to n beta I of x right? Okay. So if I just put the starred values over here, so if it is the optimal point, if you put the star value, so what do you know? This value is always less than 0, yes or no? This is equal to 0. Even at optimality, this must hold because Lj of x star has to be 0. That is the constraint from primal feasibility. In the solution sets, it must be 0, right?
Means after putting x star, this will hold.
Yes, after putting x star, and that's what I've written. After putting x star, it will hold. So now you see, to be both sides to be equal, f of x star to be equal to f of x star, this summation alpha I star hi of x star I equal to 1 to n has to be 0, right? For it to be true. Do you agree? Otherwise, you are not going to get it because you'll get another sum less than equal to 0 value.
Yes, yes.
At the optimal point. So therefore, you see alpha I star is all greater than 0. And hi of x is all less than equal to 0. Therefore, it can only be equal to 0 if alpha I star xi star equal to 0 for all I. Yes or no? Otherwise, you will get all negatives. They will never cancel. For all I, they are less than 0. Yes or no? They will be only be equal to 0 if they are individually equal to 0. Therefore, this is called complementary slackness. What does it mean? It means alpha I star hi star. This is equal to, we just write it big here, KKT conditions proof. 22nd of May. Okay, which means that if hi of x star is less than 0, alpha I star equal to 0. If alpha I star greater than 0, hi of x star equal to 0. Yes or no? Yes?
Like we took alpha is as positive.
Yes. Where is it not positive?
No. Okay. No, then
That
alpha equals to 0. It can be alpha I star equals to.
no, but we took greater than equal to 0, right? We put that's why we put less than equal to 0. Greater than equal to 0.
Acha,
Right?
acha, acha. Okay.
0 gives us the freedom. So once now we can use this to give our solution. So now I know the KKT conditions. I know my primal and dual. Let me write down the primal. Primal is minimize W subject to, can you tell me, recall? Yn W transpose Xn plus B greater than equal to 1 minus epsilon n, right?
Yes.
And the dual was just keeping in handy. I will be requiring it. That's why I'm going to draw the figure. We'll look at these points in a while. And the dual is maximize over alpha summation of I equal to 1 to n minus half correct, or whatever k of xi comma xj. This will be the general form, right? Any questions? Alpha between 0 and c. C is finite for soft SVM, and you will see that C is infinity for hard SVM, because there is no C constraint in the hard SVM, right? It can be all values greater than 0. But for the timing, we'll take C. Next, if that is true, what can I do? I'm going very slow. Please follow me. Otherwise, I thought I will finish perceptual algorithm also today. I don't think I'll be able to do it. Okay.
No, means you got the value of alpha star and
Yes.
alpha.
Okay. And what else? What do I have? Another constraint I have? What else constraint do I have? Yi
Alpha I
alpha
equals
is
to 0.
alpha I yi was equal to 0 if I remember correctly. But not remembering the thing. Yeah, alpha I yi equal to 0. Good. Now I tell you that I know the solution. Solution ki kore Pablo, I'm not telling you now. You say I know alpha star. How to get, what is your actual objective? Your objective is to get your this plane, right? W transpose X plus B, yes or no? So you need to get W star and B star. That is your actual objective, right? Otherwise, how will you plot the decision boundary? Hai na?
Is B star required? W star we have to minimize.
No, I know, but that's what when we minimize W star, we remove W star from the equation, right? You recall what we did? When I set up the Lagrangian, here it is. So I added this primal plus the constraint and found that W is equal to summation of alpha I yi xi, right? Yes or no?
Yes, yes.
And then put this value and got the alphas, the optimal, the what is objective in terms of the dual solutions, the dual variables, right?
Yes.
Okay. So I know this, and I also know C minus alpha I minus beta I equal to 0. This I know. Good. But I know already W star because W star is easy to find because I already got one equation, right? It's just the weighted average of all the data points. Yes or no? This is one I got by solving dl dw equal to 0. So if I know alpha star, I get W star directly. Yes or no? Any
Yes,
question?
yes.
I got the value of W star, alpha star. What was the objective? L alpha beta. This was half W squared plus C I equal to 1 to n xi I plus alpha I equal to 1 to n 1 minus. Yeah, so this is the negativity constraint. What will be the negativity constraint? Tell me. What are the negativity constraints? 1 minus xi I minus
ওই তো yn into w transpose xn plus xi.
minus beta I xi I. Right? These are the constraints that I have. This is the Lagrangian that I have. Now, by complement, this is the less than equal to constraint. This is also less than equal to constraint. What information do I get from these? Do you see I get this information that if alpha I star not equal to 0, what can I say? I just need one
Well,
point.
like
Ball.
dada, it should not be minus summation alpha I.
Minus.
Oh, okay,
Why?
same. Alpha I would be then greater than equals to 0. Same.
This term is less than equal to 0, right? Alpha is are always yes or no?
Inequality in negative form.
So alpha I has to be always greater than 0. I have already told you. So if it is not equal to 0, that is, you're saying this has to be greater than 0. Instead of equal, not equal to. Yeah, that is true. Not less than 0 is not possible. By being not equal to means this. This is equivalent. So if it is greater
So
than
means
0,
you
what can I
had
say?
written less than equals to 0 means that inequality part you have written.
Yeah. The entire
Acha,
inequality I
okay,
had
okay.
written. Okay. So now I ask you if it is alpha I star is greater than 0, then what? A particular slab variable,
Okay.
dual variable is greater. Yeah.
Then that part will be 0 by solution condition.
Complementary slackness. Complementary slackness. Good. KKT condition. This is the only useful condition. Others will always hold. So I can say this is equal to 0. Or I can say, but now I am not yet solved, right? What is the problem now I face? What kind of problem do I face now? I do not know these. What are these? My question, right? I have never solved for this. These did not even appear in my dual objective. Yes or no?
Yes.
They didn't even appear in my dual objective. So I will try to see where the xi is equal to 0. If I can find this xi is, I am done, right? Then I will be equal to 1. So where are they equal to 0? Where these points lie on these vectors, right? We had discussed this last time. Xi I equal to 0 and W transpose X plus B equal to 1 and W transpose X minus B equal to -1. Fine? These are called the support vectors, right?
Okay, means they don't enter into the zones of other.
Yes. So we have to find the support vectors. If we can find the support vectors, we are done. Okay, so how do I find the support vectors? Very simple. Do I see another slack condition? Beta I. This is also an inequality constraint, yes or no?
Yes.
This has to be less than 0. So if I know that beta I, if beta I star, because beta I star I know, I'll show you why I know it, is equal to 0 or not equal, is greater than 0, then I can say xi I has to be equal to 0. Right now? Again, complementary slackness.
The full thing has to be 0, that is why.
Yes. For all those points where beta I is greater than 0, xi I has to be equal to 0 from this constraint. ঠিক আছে? Any questions? Now you will ask me, Dada, I still don't know beta I. How will I get beta I? But I will tell you know it. How do you know it?
Oh,
know
that
it
C
from
minus alpha, that thing.
Yes. Where is that I wrote? I cannot find it anymore. Yes, I got it. Here it is. So I will get beta I from C minus alpha I. So if C minus alpha I star is greater than 0, which means for these cases where C minus alpha I star is greater than 0, I can write yes or no? Right now? So only in terms of alpha I'm getting the solutions, yes or no? All are only depending on alpha. Correct?
Yes, yes.
So now I multiply yi on both sides. So this becomes 1. Yi square is 1, right? Minus 1 square into plus or and plus 1 square, both are 1. So you get b is equal to yi minus w transpose x I if c minus alpha I star is greater than 0. ঠিক আছে? For all I, they'll be same b. And to get maybe a little bit of a problem you can have in the calculations, like there can be a little bit variations in the proximity of the decimal due to numerical reasons. For that, you can take for all the values of I that it is greater, you can take the average of that to be b, right? But it should be equal in theory. Okay. But in reality, 2 and 1.999999 may be different. So to get exact boundary, take the average. Okay. Any questions?
Like the equals to 0 part won't help, where it becomes 0 beta I not equals to 0. Oh,
Beta
acha,
I
you are
not equal.
using
I
you
am
are
using that
using
only.
that.
Na?
Acha, if beta equals to 0, then
Alpha, then epsilon I is greater than 0. Then we are, it may or may not be greater than 0. So you cannot be sure.
acha, acha, acha.
Okay. So before, this is the last thing I'll do. But before doing that, you did not ask me one question. I would have liked to listen to that or hear that question from you all. I'll just copy this to the end so that you does not interfere between what I'm doing. It will take like 5 minutes, 15 minutes more to complete this. I don't think I'll be able to start deep learning today. Please tell people to join maybe next class. We'll start with perceptron learning algorithm and deep learning. I thought I'll do it today, finish it off, but I think I will not be able to. I was thinking I'll do GMMs also, but I don't think I'll get a lot of time now. Only a few, three or maximum 4 classes are left after this. I will complete deep learning models, MLP, CNNs, and do k-means clustering, k-means and k-medoids, so on. Hierarchical. If I get some time in the last class, I want to do GMMs so that you let us see. So now, how do you find? Did this question not come to your mind? How do you find the alpha i's from the dual? So because your question is very difficult to ask, it's non-trivial. Maximize over alpha. Summation of I equal to 1 to n alpha I minus half. Okay. But here there is constraint, right? C alpha must be between 0 and c, and summation of alpha I yi has to be equal to 0, right? Was this the constraint?
Yes.
Again, but then Dada, you will not be able to solve this. And again, I cannot use gradient descent, right? Because again, the constraints have to be satisfied. I cannot directly use it. Yes or no?
Yes.
I cannot. So how do I solve it? So there is an algorithm called a coordinate descent, in which you optimize. So for I while converged, xi star at t plus 1 is maximize over xi. So I will be, for the time being, sorry for removing this. Yeah. So I will be referring to this as say a function L of alpha as I was defining it as. So max of alpha ith variable, right? 1, 2, dot I. I will just optimize over. So these I'll keep fixed. Pick alpha I. Set alpha equal to 0. If you start with alpha equal to 0 and see until convergence, just select over the alpha i's and see the maximum value. Can you tell me why I can do the maximum value over here? So if I just select alpha I, what will this become? Just select alpha I. Do you agree this will become A alpha I squared plus B alpha I plus C? I'll give you a moment to think and then I'll explain. Right?
Like the other T plus one thing.
Not even A alpha I
understand.
squared. It will just be. Okay, good. Good question. So it will just be B alpha plus C. So I will fix all the alphas, right? Fix all the alpha i's. Do you agree? Is that okay with you?
It's how we will fix random values.
Yes, I'll start with zeros. Zero solves all the constraints. If I put all the alpha to be zero, this constraint is valid, this constraint is valid.
Yes.
And then I'll pick one alpha. And I will try to maximize that equation for that alpha. I can do that. It's a closed form solution. I will just get, what will I get? Alpha, I'll get 1 minus summation of alpha I will go out. You will get summation of ij, j equal to 1. You'll get this huge equation, right? For corresponding to the xi's, the alpha i's. If I just put the alpha I outside, and then I can put it to 0, and this is not helping. Right? There's not a particular solution over here. Why is it not there? You can easily understand. Even if I take a linear function, it is a linear function, right? Because there's only one variable. When I fix all other alphas and select one alpha, this is just going to be a linear function, yes or no? This will be some a plus b alpha I, right? Yes or no? Again, you're not understanding. I will just let me just write it down for you. So I will just select alpha I plus, so let us even not select alpha I, let us say alpha 1 I am selecting without loss of generality. And this converges because this is a convex function. This is same as gradient descent. Same as gradient descent. This converges for convex functions. So I'm telling you, so for this alpha I, and the convergence proof has to be only done in a optimization course. So we cannot do that. So this, I will just use this and I will write alpha 1 plus summation of I equal to 1 to 2 to n alpha I minus half summation of alpha 1 into j equal to 1 to n yj. So this will be some constant, right? Some constant c. Let me write constant k1. If I just take the alphas outside, we write it if you are not following. Now is it okay? Okay or not?
Oh, yes, yes.
And I will
In a
write this from
constant
2
value.
to n, and I will add another term, say alpha 1 summation of j equal to 1 to n alpha j yi k xi xj. Just depends. So this is nothing but alpha 1 sum m times alpha 1 plus n, right? And between 0 and c, I can find these values. But can you tell me what is, because the maximum value will be at the end points for linear functions. But can you tell me why is there a drawback for this? What is the drawback? Because at the end of the
Like
day, this
alpha 1 maximize, if I maximize, alpha 2
yes,
will drop.
that has to drop, but here it is not dropping, right? If I maximize alpha I, alpha true has to minimize, has to decrease. Others have to decrease, right? Right? Have to decrease other two, otherwise this constraint will not hold.
Yes.
But I am only doing for one alpha. Will it work ever? For one alpha.
Oh, like you are saying simultaneously we have to do.
Simultaneously to do two of the alphas. Then only can I guarantee that I can make them sum to be 0. Right? How can I do that? Say I start at iteration t. So this for one alpha 1 I, it will not work. Not work as this constraint is not satisfied. Not satisfied. Okay. So now to make it work, what can I do? Say I select without loss of generality alpha 1 and alpha 2, I will maximize, right? I select two of these. Then can I write y1 alpha 1 plus y2 alpha 2 equal to minus of I equal to 3 to n alpha I yi. Can I write? This is very interesting. This is
Yes.
called the simultaneous minimal optimization. Or not simultaneous, sequential minimal optimization. Sequential minimal optimization. Why is it called minimal optimization or SMO? Very important algorithm when it comes to your exam. People may ask you, and this can be the thing of difference because people don't know how to actually solve SVM. They give it to a solver after they find the dual. But now you will be able to solve it yourself. Right? If this is true, if I take it back to the other side, it is 0. I am taking these two values and I'm setting it to the negative of the other sums, right? Okay.
All right.
And I put it to k. We pay attention to this. It is like class 11 maths, but this is very interesting. Alpha 1 y1 I can write as, can I write? So I'm writing this as capital K or small k, whatever you like. So alpha 1, or let me write alpha 2 as k equal to alpha 1 y1 by y2. Yes or no? Do you agree?
Yes.
I just subtracted the, this is constant. I know the constant now, right? At a particular time t, at tth iteration, I know the constant. Because I know I will sum the other values. Okay.
All right.
Good. Now, what do I do? Now, and remember, how do you select alpha 1, alpha 2? Select them from points that does not satisfy KKT condition. If they're not satisfying, if they're not optimized, you can optimize them. That's the idea. You can just see the values which are not satisfying this constraints and then select those. For these two constraints must always be satisfied. Other than that, you will try to see points which are not lying on the line and you will try to optimize for those points. Using this KKT condition, this slackness condition. And you will get the xi, yi's, right? Which are not becoming zero. At a point when they become zero, you are solved, right? You'll get 2 points from this, wherever this alpha star and this inequality constraint is not equal to zero. You select those 2 points. And if you're not following, please go back and think about it. How you select the point, because selecting a point has to depend on ones that have not been optimized. But once you have selected those points, I can solve it. So see alpha 2 I can write in terms of alpha 1, yes or no?
Yes.
And now do you agree this alpha 2 and alpha 1 has to satisfy k? Alpha 1 y1 plus alpha 2 y2 has to be equal to k. And therefore, after end of optimization, I equal to 1 to n alpha I, say new ones, yi has to be equal to 0 because I have selected them like that. Yes or no? But there is a problem again. What is the problem? Remember, alpha 1 and alpha 2 have to be between what? Between 0 and c. Both, no, I'm comma.
Okay, yes.
So I have control over alpha 1. So I am saying alpha 1 is between 0 and c. I will select alpha 1 between 0 and c. Okay. But how will I select alpha 2? Is my question. So now do you see? But before I go into that, do you see the objective? The g of alpha 1 and alpha 2 can be written as a alpha 1 squared plus b alpha plus c. If you're not following, since right, this I will write it as only for alpha 1 and I will write k minus alpha 1 y1 by y2, right? For alpha 1 and alpha 2. Right now?
Yes.
So what rest are constant. So what will you get? Alpha 1 squared. So it will be a quadratic in alpha 1, yes or no?
Oh, yes.
So this will be only alpha 1 plus k minus alpha 1 y1 by alpha y2 plus dot. Others are constant. And here only this term will be remaining with the other terms that this m constant are rest are all constant, right? So I can write G as a quadratic, right? And I know how to optimize a quadratic perfectly. I don't need a solver. I know closed form, right?
Yes.
Alpha 1 star is we'll see which one we require. Right? Quadratic you can maximize, right? Without even doing gradient descent and all those methods.
Yes.
So, but can you tell me what is the problem I'm presently facing? If I just put the value of alpha 1 and alpha and these two values in the equation, am I guaranteed that both of them will be between 0 and c? I'm not guaranteed, right? There is no guarantee to say that. I have not used that constraint anywhere.
Yes.
So now you see I can do. So this must be between 0 and c, right? So I will multiply numerator and denominator with y1. So if y1 equal to y2, that is same class, then what can I do? So this becomes 1, right? y1, y2 equal to 1. Correct? I multiplied and divided. Okay. So this case I am doing case 1, case 2, where if y1 not equal to y2 is your homework. So this is a y1 minus alpha 1 y1 squared less than equal to c. Yes or no?
Yes, okay.
So this is equal to 1 again. So I know that alpha 1 has to be between what? Rather minus alpha 1 has to be between c minus ky and minus ky 1. Okay, which means alpha 1 has to be between ky1 minus c and ky1, right? Okay.
Yes.
I just inverted the inequality over here. 1 plus alpha 2 y2. Yes or no? The old values of alpha 1 y1 and old values of alpha 2 y2. Yes or no? This is the new value. Okay. This is equal to alpha 1 plus alpha 2 since y1 equal to y2 here. Okay. And what do I know about alpha 1 new? This has to be between 0 and c. So including both this constraint, alpha y1 new has to be between max of 0 comma alpha 1 plus alpha 2 minus c and mean of c comma alpha 1 plus alpha 2. Okay. Clear? Any questions? I'm waiting, and then this is the last thing I'm doing, and I'll finish it a thing off with a simple regression question. Is this okay?
Yes.
Which part did you not follow? You can tell me. So alpha 1 first constant is giving you between say a1 and b1, and second is between a2 and b2, right? So it has to be between the max of a1 and b1 and a2 and b2. And it is not possible that b1 will be less than a1. You can check that easily because a1 plus a2 has to be less than equal, has to be greater than c. Alpha 1 plus alpha 2 not greater than c. This has to be greater than 0, right? Agreed? Only difficulty is when that is less than 0. Then you will not have an intersection, right?
Yes.
So now I know exactly the points between. So this is A, this is alpha nu B. I know to solve alpha 1 right now, alpha 1 and alpha 2, because I have a quadratic. And quadratics I can maximize. There can be multiple cases between which I can maximize it. Say this is A is, in this case, A is positive, A is greater than 0, x squared plus bx plus c. Right? So this will be your maximum. In this case, if A is negative, and this lies between the constraint, this is your maximum. Similarly, if it is outside, then this is your maximum. If it is inside, then this is your maximum, right? You can easily solve closed form solution like if else likhe, 4 5 if else, 5 conditions. This is your class 11. This was one of the things that you did in quadratic equations chapter. You know exactly where is the maximum, right? For in a range of a quadratic.
Yes.
So now I am done. I can solve it now and you will get all the alphas. So this gives you the complete algorithm to do SVM. Okay. So the last thing for
one
today.
thing to ask means you
Yeah.
were doing using alpha 1 and alpha 2. So then we will do alpha 3, alpha 4 like that.
Exactly. So you start from alpha 0, alpha 1, and you select the first two data points that do not satisfy these KKT conditions. I told, right? Where is the KKT condition? Yeah, here it is. So wherever alpha I 1 minus, this is the optimality condition you want, right? Yes or no? So if this is greater than 0 and this is not equal to 0, you keep on selecting those alpha i's, right?
Achha.
Right now, at the end of the day, you will be solving this entire equation because at the end of the day, you know the values. There will be no such constraint that will be left, right? You can also select randomly; it will still work. But to be efficient, this is better. अच्छा, ठीक है. So the last thing is for today is before I show the code for SVM, this will just take 2 minutes. Say I want to do SVM for a regression problem. Then now you see what do you for a regression problem. So this solves your. So I'll give you one homework. Please write a program to maximize a quadratic in a range. So range will be given to you a comma b or r1 comma r2 and ax square plus bx plus c will be given. Only if else blocks allowed. So step 1 must be solve it in pen and paper. This can help your maths also. Please do it. Okay. I hope you'll do it. It's interesting, right? The same thing which we found in the case of a SVM. So SVM for regression, if I am telling you to do. So in case of regression, what do? We fit a line to the data, right? We remember y equal to W transpose X plus epsilon. We try to estimate this, right? Agreed? By minimizing the error y minus W transpose X whole square. This is what we do. This is your linear regression model. But again, if I have to make it support vector case, what will I do? I will do something like this. I will select an epsilon bound such that I want all these data points to be between those epsilon. Is this understandable? There we were separating it. Here we are bringing it together. So what should be your SVM equation or your objective? The primal objective, minimum over W, same thing, W squared plus, can you tell me what will it be? If I want a soft a margin classifier, that is between W plus minus W, do you see that this will be this max of 0, this is called a hinge loss. We'll see this in perceptron also, perceptron algorithm. So I am taking x to be 1, x, so that there is no question of thinking about b's. You don't have to think about b over here. Is this okay? So what do I mean by this? This is my error. This or this. This is my W transpose xn minus yn. ठीक ना भूल? This is my actual yn, and this point is W transpose xn, right?
Yes, yes.
So if this is below epsilon, so if you subtract epsilon from it, this will become negative, yes or no? For this point, epsilon is this value, it is greater, yes or no?
Yes.
So if already in the border, don't penalize. Right? We penalize these models for being always, we penalize, right? We always put a loss. But in SVM, we will not put a loss. This is called support vector regression. Okay. We will not put a loss at all. Normally, if we would put this loss, right? W minus W transpose xn whole square. MSE loss for that point, whatever error it was making. But I will say if it is already within this epsilon, I will not give it any loss.
Means the closest vector has been found within epsilon bound.
Yes, good. So that, but if it is above epsilon, then I will give it that loss, right? If it is above, then I will give it this loss. This will be my loss, right? So if W transpose xn minus y is greater than epsilon, loss is equal to W transpose xn minus y minus epsilon. Else 0. That's what this equation shows. Yes or no? Maximum of this. Yes or no?
Yes, yes, yes.
This I'm writing this in terms of a maximum function. That is max, either it is you are giving some loss, otherwise you're not giving any loss. If it is above the boundary, you give it a loss, otherwise you give it 0 loss. Right? If it is negative, you will give 0 loss within the boundary. Okay, so this is called a hinge loss. So SVM uses hinge loss, both SVM and SVR. Your homework is to research what hinge loss, or find out what hinge loss SVM uses for classification, which we showed using this geometry. We can also show it in terms of this loss function. Okay. So now, so this is my objective. This is my objective. Okay. So now you have to introduce some combinations. So there will be, so I have been able to, how do you learn? We have told. Now I have to introduce something called slack variables also. Right? I have to introduce slack variables. So I'll just copy this over here. Now you tell me, if there were data points outside this, there will be sometimes data points which will be outliers. How will I treat them? So I will treat this extra thing as a slack. Okay. So if it is above we will say epsilon positive, and if it is below, I will say xi negative. Clear? Yes or no?
Okay.
So then what can I write? I can write W transpose Xn minus Y. For the time being, that can be equal to some xi I or yes or no? So whatever this was, so for example, if this is the data point, this is your W transpose Xn. So this value W transpose Xn xi minus yi. If I subtract this epsilon, I get this slack. Yes or no? Right? I get this slack. If I I think it has still not come. If I subtract this slack that I have epsilon, I'll get this. If I subtract the bound, I'll get the slack. Yes or no? Is it clear?
Yes.
So it does not have to be equal to. It can be less than equal to, right? Because I'm putting slack variables, I want it to be less than equal to. Okay.
Yes.
But there are two cases here. Can you tell me what are the two cases? If W transpose Xi minus Y greater than 0 and W transpose Xi minus Yi less than 0, right? In both those cases, you will have different slack variables, right? A positive and a negative slack variable. So you will get W transpose Xi minus Yi minus, so which is this case when the prediction is above? Is this the negative case or the positive case? When the prediction is above, W transpose X is the prediction, right?
Y is below.
Below. So it's a negative case. So I will write this as less than equal to xi I negative, right? Correct. The other case, I will write yi minus W transpose Xi minus epsilon, not I is not there. Epsilon is the high design parameter, less than equal to positive. Yes or no? But you don't know which is above, which is below. So for this, both the slack variables have to be used. So you will be using, your objective becomes, people use this objective. It is equivalent to writing minimize W. See, it is like your SVM only, but you will have two slack variables. And I will ask you this question just now. Just think about it. Why two slack variables? Subject to Okay, with that we have finished SVM. And then we can use the same process. Same process as SVM to fight W because it's the same equation again. Now you tell me if I ask you why did I use two slack variables for one data point? What will you tell me? If I ask you why do you use two slack variables for one data point? It's a crucial thing to understand, crucial catch. Why two slack variables? Can you tell me?
Like y minus omega, I mean, w transpose x, that we are taking mod, so it can be
That is
both
true, but if you
above and
already
below.
knew, okay, that is okay, that is true, but that is from the but do you actually know which point will be above, which point will be below?
No.
You're not still feeling interesting. See, if it is not above or below, if you do not know, you'll have to consider both the cases, right? And the model will have to find out which is where it has to place it. It has to give you have to give the model equal opportunity, right, to place it above or below. And that is why you are using that mod function. If you do not know, say at another day, if I put a decision boundary like this point can also go below, right? Say you started like this. Say your beginning of W was something like this. But you are not sure, right? Which point does this should this be above or below? Actually, this should be above. At a particular time, you're trying to see which one is being minimized actually, which one is giving you the best value. So you're giving the model both the slacks. So it will select the positive or the negative slack depending on the where it should be placed. But you should give opportunity to the model to place it either side, right? Not tell that the positive example is the positive example, you should place it to the positive side. Unlike in classification, where you tell the model that this is positive example, should place it at the positive side.
Yes.
So to give, because you really do not know where it should be, therefore you add two slack variables. So if you do not have any questions, I'll just take 2 more minutes and show you the code which is used to solve an SVM. So we have seen linear regression code. I've also shared the code with you. You can have a look yourself, but I'll just go through the code for 2 minutes. Any questions? So with that, most of the linear machine learning algorithms are over. We'll begin with like using deep learning models to solve these problems now. So okay. So if it is clear to you, I'll stop sharing the screen. Okay. Can see my screen?
Yes.
So here you see, I got to do it for the same iris dataset, just as a toy example. So you will use the sklearn library to import the dataset. So these are the normal packages that I'm using. Convex Pi will solve the convex optimization problem that I taught you today. It will use the same funda to solve it. I'm not solving the convex optimization problem myself just to save time. That will be your, if you want to do it, please do it. This is very important to do it. Most people won't tell you to do it, but since you know the algorithm now, try to do it. I'll load the dataset and I will divide the dataset into two parts. That is versicolor versus virginica. I'll select two of these data sets, right? So what SVM do I need to separate these two flowers? So there is petal length and sepal length to separate them. So what should I use? Should I use a hard SVM or a soft SVM?
Like they are mixing in a very
Yes.
small region.
But even if it is a
But
small region we saw, right, then there will be no solution.
for hard SVM.
Hard linear SVM would do, right? We don't need a kernel. So let us see. So I give you the data X, I give you Y, and I tell you to learn it. So see, so I will make the Y's that are -1 or +1 into a diagonal matrix, right? Yes or no? And then I generate the X tilde that I generated in our data as Y diagonal into X.
Achha.
If you're not following, I will. Is this the one? Okay. I'm trying to make the vectorized form. So we saw that it was the X tilde times X tilde X tilde, right? And X tilde was Y into X. Y dot X. It is come. This was your X, Y, G value, isn't it? Can you see? I'm moving my cursor.
Achha, you have made the text tilde here. Okay.
Yes, I made the X tilde over here, Y diagonal into X. And then what did I do? I made put the G. I put the G as an object in this class CVXPy. So for doing that, you add this optimizer.parameter and you give the shape of that parameter, that is n cross n, right? Y.shape0 is the number of training examples into number of training examples. And then you put X tilde, that is the G value we need, that is the value. Yes or no? That is the G. And we
Yes.
say that it has to be positive definite. We say that. Next, we use a one-hot vector. This will give me, why do I use a one-hot vector? Because I want to do alpha transpose 1. Yes or no? This is the objective I want, right? This objective I want. So I do a alpha is equal to, I put the variable alpha, which has to be my dual variable. And I just do the loss function as 1 times 1 dot alpha minus the quadratic form alpha G alpha transpose G alpha. Is it clear? Quadratic
Yes.
form. Yes, and then I just tell the optimizer to solve this dual problem. And the constraint I give the optimizer that alpha must be less than C and must be greater than 0. Right? This has to be solved using the SMO algorithm that I taught you. So I gave you one of the module to do yourself now, finding the quadratic maxima. And this is the alpha transpose Y equal to 0, right? These are the three. Summation of alpha I yi equal to 0 means alpha transpose Y equal to 0.
Yes.
This at the rate is dot product, okay? Wherever there is at the rate. And then I solve it. So once I solve it, the value is put in alpha dot value. Alpha is an object, value is the value of the object. And if you just do X tilde times alpha, it will be done, right? That gives me the summation of alpha I, yi, xi. X tilde has the y's and the alphas, right?
Achha, yes.
And then I'll get the W. And then I asked you the same question. Where is it not close to 0 and C? At those points where it is not satisfied, I will select that index because that is the point where I actually going to get the value, that is get the value of B. For B, I will just put as Y minus W transpose X, right? That's how we found wherever the value of. So what did we see? I'll just go to that part. C minus, where is it? I could have also used this directly, but I used this longer format. So I could have used this directly. C minus alpha I greater than 0, wherever this is true, I will select that index and I will do B minus that, right? B equal to, where is that? There it is, right? B minus W transpose Xi. Clear for that data point? So I'll get W and B, I return the W and V values. So let me do a SVM for a C value equal to 10. And let me plot it. So I'm getting a large margin classifier, yes or no?
Yes, yes.
Similarly, for a hard SVM, I can put the C value to be very, very high. I can give it enough room to be as high as it possibly can. See, now when I do that, these W's become out of control. They're becoming larger, right? So SVM is also like a regularizer on W. It automatically puts that regularizer I was talking about in the linear regression. See, it is giving some error now that optimization is not converging, but still it is working, but it is giving me a smaller decision boundary, right? In this case, this was much wider, but in this case, it has shrinked, right? Because I gave it a lot of C, I penalized more, right? So I couldn't use the slack variable more often, right? This is the objective, right? Where is the objective? The primal objective of the SVM? Yeah, here it is. So if I penalize C with being more, where C being more, then the slack variables has to become less, and therefore they must keep on converging to the same, this only one line. If I put a very large value, this will not even converge because this becomes a hard SVM and there are points that are mixing between red and blue. It doesn't converge. This gives me an error, failed to solve. Okay, so you saw that hard SVM will not work in case there is a mix in the data. Any questions?
Why did you say that kx comma y?
Kx comma y, where? C.
Okay, you did a hard SVM, so okay.
Yes, I did a very, I see the training I did C equal to 2000. That means I made the i's to be very small, which means that I had no room for any slack. So I had to give the exact decision boundary, which is not possible over here. Okay.
Okay, understood.
Okay, any more questions, or I can stop sharing? I'll wait for a moment. Okay. Stop sharing. If you have any questions, any general questions, with that we have solved all machine learning problems that are generally there. We'll go into perceptron learning algorithm and deep neural networks next day. Okay, and then finish it off within a couple of days, and then go to unsupervised learning. But by now you should be able to understand the foundations, how are decision boundaries being built, how are the algorithms being trained over the data, and so on. Okay, if no more questions, I'll stop recording.